Okay, guys, so we've did a quick discussion in terms of the first differencing, fixed effects, and then the CRE method. So, as usual, I want to try to just do a quick example of the structure of how we do this in R. It's not going to be too much of, well, too big of a difference from what we have in terms of Stata or whatever program you are using. These are so ingrained in what we do nowadays that basically the methods are pretty much straightforward for what we do in terms of these methods. Basically, we have the wage pan data set again, coming from the Wooldridge package. I tried to fix my links, but I'm not sure if that worked or not. Of course not. I'll have to go back again on that. But basically, it is very similar to the Mirage data set that we were looking at before. So we have wage. My fault, I should have had it a t there. So this whole equation looks wrong because there is no t dimension, but in reality there is. So we have wages that are changing over time. Now, notes, education, black, Hispanic, are not going to vary over time. Okay? This is one of the things I was talking about before, that we have a variable that basically is time invariant, and it might be one of the variables of interest within what we do. And so if it is, might just basically end up being a very bad way of doing it. Okay? Because we would remove those particular aspects. So this is one way of looking at this before you actually run any regression. And in Stata, they do a pretty good job of creating these commands that allow you to see which ones are varying, which ones aren't. What I did was I used a package that's very similar to what they have in called xtsum. It's just the R version of it. And it allows me to look at the variables, and then basically I can look at the overall, between, and within variation. And this is how I know that the within variation of education is 0. Basically, the person that has an education, nothing changes over time. And this is where we might be stuck with some of the methods that we've sort of discussed. In terms of married and in terms of union, you can see that we do have variation. Union in this case being the fact that either I'm part of union or I'm not, as an individual. Married, similar, either I'm married or I'm not. So in this case, again, this is where I should have added t's to the experience squared, and I should have added the t to married, union, but again, not to the AI term. This is that part that we're going to be thinking as the unobserved heterogeneity. So if we were going about this as an estimation, let me just show you some of the code as well before we get there. Hold on. Yes, this one. So in the case of the model, so I'm actually throwing in the dummy variable, least squares dummy variable model here, just to give a good, overall account of the different methods. So in this case with the model.dv, or dummy variable model, you can see that what we do is we could add in our data set, which is wage pan, but we're only using the LM. And what I'm going to do is I'm going to factor on NR in this case, and that's the ID of the individual. Basically, I just know that from the data set itself. In the case of the fixed effects of the first differencing, we can use a package called PLM, okay, panel linear models. In this case, we just have to tell it what the index is here. We tell it the index is NR and year, And we want to model the within variation. Basically, we want to demean it with respect to the average with respect to each individual. Okay? But you notice what I did here is I actually, even though I know education doesn't change, I know black doesn't change, I know Hispanic doesn't change, I kept them in there. I want to see what the model does when I leave them in there. And then we have the first differencing. Basically, I tell it the same information before. I tell it the index, and then I tell it I want to use the FD method, basically first difference. Okay? So those three are pretty much standard. Okay? There is a package, I can't think of off the top of my head, that will run what's referred to as the correlated random effects. Sometimes we call it the Chamberlain-Munlach approach. It has several different names. But there is a CRE, it's contained within a package. I just can't think of the package right now. But it's easily enough to do this by hand. Basically, all we would need to do is take the averages across the time-varying variables. Now, I went ahead and did this just because it was just like I know all the variables, so I just list them real quick. But the mean of the first three are meaningless, right? You know, because the mean is what it is. I mean, it's what the individual has. So basically, what should happen, because of my laziness, basically, but I'm hoping it happens, and if it doesn't, I'll just have to go back and correct it. The education bar, the black bar, Hispanic bar, and I'm pretty sure in the previous one that the experience should fall out of the other regressions as well. But here it'll stay. And from that, I should have removed these three, and we'll see what happens when I didn't do that. But in this case, then I have just using the same PLM model. And the reason I'm using the PLM is there's one little correction. Remember that RI term that when we substituted the AI model into the equation, we ended up with a composite error term. Well, what we have to do is we have to adjust the standard errors. So there is an adjustment there. So that's why we usually prefer to run this with what we call random effects, even though we're modeling it as a correlated random effects. Okay? In this case, I still tell it what the index is. Okay? So if I run that and everything is run properly, let's see. Then what I should get is a dummy variable model. And basically, you see that, why shouldn't these have fallen out? Or should they fall out? Remember, y'all told me y'all knew everything about these models. So I included them for a reason. I wanted to make sure that, so in this case, I should have removed them myself. All right? They're not varying over time, then I need to remove them. So I just wanted to make sure that you know that. So just because you run a program, it's not going to do what it's supposed to. It thinks that you know better than it. Okay? So I should have removed them from the model. Okay? So in this case, I should have removed these three, because then basically I would only see the variation across these particular four outcomes. Because it does it exactly what it's supposed to do here. Right? It removed what it's supposed to remove. So in this case, everything matches up perfectly, including the standard errors, because we did a little tweak on them within the estimation. Okay? So just note, when you're looking at these three, they should have been removed.
So standard practice is not included?
From what I know, yes. Like I said, there are always changes on how the practice goes. But I've just seen it in the past that basically somebody will run a particular model and it says, you know, he just includes all the right-hand side variables he included before because he just assumes the package is going to do what it's supposed to do remember the packages, the tools and things like that, they run and really try to run exactly what you give it because it thinks you know better than it. So that's why even though you're using these packages, this is what I mean by the fact you knowing the data, you know the procedures, all that stuff. You need to know them and not just trust whatever comes out of the packages or the models. Okay? And remember what I was talking about before, that basically those things that change by 1 for every single person in the first differencing model, it's gone. Right? It's been removed because it can't, basically it starts to get confused between those things changing by 1 and the constant it's supposed to include in the model. Okay, so it's been removed. But experience squares stays in there because it is a nonlinear term. Okay? And then in terms of the CRE method, the CRE method, like I said before, education, black, Hispanic will stay in. Those changing by 1 stay in. And even though we estimate these, you can try to put some meaning with them, but basically a control is just a control. Remember that side. So most people wouldn't show that particular thing, but you can try to pull some meaning from those. Because remember, they are trying to model the fixed effects portion of it. Yeah.
Oh, okay. I would love to know, like, to say, how then did you capture for those level of confidence, like on the codes? Because you said it's not advisable on the first days to add them. Those to add them, it's better to show them on the codes, not to copy and paste. Meaning, like, how then I want to see that part where you insert codes in terms of, to say, like, 0.1 confidence. I mean 0.1, 0.05. 0.05, 0.01. Those star, 1 star, 3 star, 2 star. Those star, I'm referring to those stars, yes.
You mean this?
Yes, but on the output model itself, on the output results, yeah. To say,
You're saying from the R side or from this?
how then I can navigate to show
So the package I'm using here is just Stargazer, so I get it to do most of that for me. That's what I'm saying. The thing we were trying to do the very first day was basically show you those things you spend hours on, trying to reshape the data, create the tables in Excel or anything like that. We were trying to show you that there's an easier way. And one of those, in this case, is Stargazer works for a large number of different types of packages. Not all. I'm going to show you, there's one later on that I'm going to show you that basically it does not work with that package. So you have to find an alternative, or you have to do some crazy steps to get it to work. But always try to use these packages. So I didn't specify in here, but it's a default in Stargazer to have 1 star for 10%, 2 for 5, and then 3 for 1. But you can adjust that to make it different levels. I've seen it where they go, for some reason, not 1%, but they do 0.001. I'm not sure why. But that's the standard. But there's a few other things that you can do in here. So one of those that, one of the things I really like about Stargazer and these programs is basically, so I ran the dummy variable model a second ago, right? And there should have been, I can't remember the number, but there should have been a lot of, additional variables. But that program, Stargazer, allowed me to basically say, omit those. I don't care about the dummy variable coefficients. Don't put it in my table is what I'm telling it. So I can omit certain things as well. If I had actually tell it to omit the bar, basically it would have thrown those out as well. So that's the thing about these programs. Basically, it stores information. It even keeps the alignment the right way. So it aligns all this for me. So it knows that union was in one, but maybe it wasn't in another one, and it'll keep it as blank. It's a huge time saver in this case, especially for these dummy variable models. Okay. So yeah, this is one to use. There's one, like I said, called TextReg that should show up in my code sometimes, and then one called ScreenReg. But the strange thing is, because of the way the packages are built, when you actually run the model, the class that it's defined as, in this case, would be LM. So Stargazer works with LM, it works with PLM, and so those classes it'll know to work with. But if it doesn't recognize a class of another package that you create, it won't, the table won't work well with it. Okay? So yeah, so this is the thing about it. So even though I was trying to force it, so the PLM on these two cases were right. It did what it's supposed to do, even though I just kept the equation exactly the same. This one doesn't matter as much because basically I know that it's supposed to keep those in. The reason I wanted to show this first one, though, is I wanted to make sure that you know if you do this, somebody's going to point out those should have fallen out. The top three there. They shouldn't have been in there.
So when you explain your table, when you communicate to the reader, how do you then explain your exclusion of the fixed categorical variables?
Fixed.
Like the fixed one, like the things that don't change.
Oh, because they're time invariant. Basically, any type of process that demeans or subtracts off or with the within transformation, once you do that, they're set to 0. You can't estimate something that has no variation. So that's why they're gone now. And some of the programs, like I said, are smart enough to know to drop them, but if you use other standard programs, they don't know. They're going to try to force their way in to estimate them. Okay, so just keep that in mind, that you're supposed to know that more than someone else, so they most likely will point it out to you. And it's usually not a little bit embarrassing. Okay, so yeah, that's the only reason. So it's to say any time invariant variables fall out. Here, the time invariant variables fall out, and anything that only changes by 1. In this case, experience. If everybody's always getting the same increase in experience, it's going to fall out. Okay, because it can't really differentiate that from the constant. Okay, so these are just some of the outcomes. Now, note that this is not perfectly correct right now. Because one thing that I didn't account for, I only accounted for the year variation. Or sorry, the individual variation, or unobserved variation. I didn't actually put in dummy variables for years. We always usually would want to include, systems to account for the unobserved heterogeneity for the individual, then also the year, average impact across everyone. Okay, so if I put that in there, that would make one more adjustment as it goes. Shouldn't be too far off, though, from this. So I wanted to try the same thing. You've seen the code. Yeah. Yeah. No, it's not time invariant. It's moving by 1. So education is time invariant. We have your education. We're looking at people that are out of school. So basically, your education is set once you start in the panel, and it never changes across. If you have matric, you always have matric. So once we difference out the outcome. So if you have matric and we take the average for the person, then that would always be 12. So 12 minus 12 is removed. Same for all the other individuals. Experience, each year I'm working is increasing by 1. So what is the difference between that? It's 1. Remember, our matrix of our covariates has a 1 as a constant already. So that means there's a problem in trying to identify experience that's only moving by 1. So these are problems that are associated with each of the models.
Okay, so with education, it would basically like categoricals to say like high school and then university and all of that. Because I'm thinking if a person has matric and then they go to university.
But we're only looking at working people, not people that are still in school. So think about it as we're not going to have anybody identified that's 16 years of age. So we won't see them in 2 years when they, graduate or then go to university. Think about these as people 30 years and older. If I had the link, I would be able to know exactly the age. But what we're seeing is only people working. The education we're seeing is what it was fixed to when they left. Either they had matric, they had university. But after you get that, nothing changes across. So we're not viewing people that are continuing on with their education. So that's why it's fixed.
So is it making the assumption that no one is like studying in their time of work?
No, we're actually only viewing people that are out of school. Okay, that's the way sort of the outcome was observed. That's why whenever you remember the table I showed before, the within variation, this right here shows me that there is no change for anybody within the sets for education. And that's why it falls out. I could have done race here as well, but it would have shown the same thing. That's why I chose to make sure that you understand that people do get divorced or married within the sample. And sometimes you join a union, and then sometimes later on you get another job that doesn't. So these are things that I just wanted to show within here, that we do have variation within these 2 variables, but not within education or within race in that case, because it's white, Hispanic, and black in the data set. Okay, so that's why those things are falling out. But like I said, you have to be careful with this, because I've seen programs that, for whatever reason, it can be the program picking up something that a little strange. Sometimes you think you have a balanced data set, but then if you actually look at it somewhere down at the very bottom, there's NAs, there's things that are missing. And because you have attrition or something else going on, it might almost appear to the computer program that it's variation, but it's not. That's why you have to be careful about what variables you're putting in there. You have to know this doesn't vary, this varies. What's going on with this variable? Once you know that, you make sure that you didn't do what I did and just basically copy and paste the equations in. Okay? Because it's always going to try to do exactly what you asked it to do. You got to make sure that you ask it with the proper things identified. Okay? So we're going to just practice the same thing. We're going to take the same exact equations we had before. This time I properly put the t's in there. I didn't forget them this time around. But this time I want you to remember I told you throwing in the year dummy variables we typically need to do to get that aggregate effect across our sample within that year. And then within the data set there's also occupation. There are 9 of them. So if there's 9 of them, how many new variables do we have? N minus 1. So 9 categories, 9. That means 8 new dummy variables. Okay? N minus 1 outcomes. Okay. So I want you to run this for fixed effects, first differencing, and the correlated random effects model. I think 20 minutes should be fine. Let's do 20. Just so we can finish, and then I can kind of go over it with you as well. Okay? So 20 minutes, we're using the wage pan data set. We're going to be using the PLM package. And it's the exact equation we're running here. So these two should be straightforward, right? But make sure you only put what's required within the equation. Don't just throw in everything. Okay? Make sure that you're keeping track of what goes in and what doesn't. And then we'll come back in 20 minutes to kind of walk you through it. Okay?